Alright, so in this equation, I have x to the power of 4 plus x squared is equal to 20. So to solve this, what I'm going to do is first start by subtracting 20 on both sides, so we can have all our terms on one side. So I get x to the power of 4 plus x squared minus 20 is equal to 0. Now this may seem like a quadratic equation, but it's not, because we have the power of 4 as our primary term, and then that's led by the power of 2. And in a normal quadratic equation, we have 2 as our primary, then we just have 1, and then we have some constant c. So how are we going to solve this? Well, we can't factor this out by using the quadratic formula, because this is not a quadratic equation. So to solve this, what I'm going to do is rewrite this as x to the power of 4 plus x squared minus 16 plus 4. So I rewrote 20 as 16 plus 4. And the reason I did this is because negative 16 is the same thing as negative 2 to the power of 4, and negative 4 is the same thing as negative 2 squared. So now notice how I have something in the power of 4 and something in the power of 2, and they're both the same. Now I can put the powers of 4's together and the powers of 2 together. So I get x to the power of 4 minus 2 to the power of 4 plus x squared minus 2 squared is equal to 0. Now 2 to the power of 4 is 16, and 16 is the same thing as 4 squared as well. So I get x to the power of 4 minus 4 squared, and I have this plus x squared minus 2 squared. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 4 is the same thing as x to the power of 2 times 2, which is equal to x to the power of 2 to the power of 2. So now I get x to the power of 2 to the power of 2 minus 4 to the power of 2 plus x squared minus 2 squared is equal to 0. Now notice how everything is in the power of 2, and if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So we're going to use this property on these two groups. So I first get x squared plus 4 times x squared minus 4 plus x plus 2 times x minus 2 is equal to 0. Now we can use this property again on x squared minus 4 by rewriting as x squared minus 2 squared. So that's going to equal x plus 2 times x minus 2. And I have this plus x plus 2 times x minus 2 is equal to 0. Now I'm going to factor out x minus 2, so I get x minus 2 times x squared plus 4 times x plus 2 plus x plus 2, which is equal to 0. And notice how we can also factor out x plus 2 as well. So actually at the start, what we could have done is just factored x squared minus 4 out, but now we're going to factor out x plus 2 as well. So I get x plus 2 times x minus 2 times x squared plus 4 plus 1 is equal to 0. So x plus 2 times x minus 2, like I said, was x squared minus 4. And I have this times x squared plus 4 plus 1, which is x squared plus 5. Now this is equal to 0. Now this gives me two equations. I get x squared minus 4 is equal to 0, and I get x squared plus 5 is equal to 0. So for x squared minus 4 equals 0, I can add 4 on both sides. So I get x squared is equal to 4, and this is equal to positive or negative 2. And for x squared plus 5 is equal to 0, I get x squared is equal to negative 5, and I get x is equal to positive negative square root of negative 5, which is equal to positive or negative square root of 5i. Alright, so in this video, I'm going to be solving the equation 25 to the power of x minus 5 to the power of x is equal to 20. So to solve this equation, I'm going to first start by subtracting 20 on both sides. So then these two cancel out, and I get 25 to the power of x minus 5 to the power of x minus 20 is equal to 0. Now 25 to the power of x, I can rewrite this as 5 squared to the power of x. So I have this minus 5 to the power of x minus 20 is equal to 0. And now from here, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. And a to the power of m times n, I can rewrite as a to the power of n times m. So if a to the power of m times n is equal to a to the power of m to the power of n, then a to the power of n times m should equal a to the power of n to the power of m. So 5 to the power of 2 to the power of x is going to equal 5 to the power of x to the power of 2. Now I have this minus 5 to the power of x minus 20 is equal to 0. And now I'm going to let 5 to the power of x is equal to y, so I get y squared minus y minus 20 is equal to 0. Now, to solve this, I'm going to be using the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 1, and c is negative 20. So I get y equals negative 1 plus or minus the square root of b squared, so negative 1 squared, which is positive 1, minus 4 times a, which is 1, times c, which is negative 20, all over 2a, so 2 times 1. And this is equal to 1 plus or minus the square root of 1 plus 80 over 2, which is equal to 1 plus or minus the square root of 81 over 2. And the square root of 81 is equal to 9. So I get y is equal to 1 plus or minus 9 over 2. Now this gives me two solutions. I get y equals 1 plus 9 over 2, and y equals 1 minus 9 over 2. So 1 plus 9 is 10, and 10 divided by 2 is 5, so I get y equals 5 as one solution, and 1 minus 9 is negative 8. Negative 8 over 2 is negative 4, so y equals negative 4 is another solution. Now from here, remember how we let 5 to the power of x equal to y. So this means I get two solutions. 5 to the power of x is equal to 5, and 5 to the power of x is equal to negative 4. So let's look at this equation over here. 5 to the power of x equals negative 4. Well, we can't take the power of a positive number and turn it into a negative number, meaning this equation has no solution. And for 5 to the power of x equals 5, to solve this, what most people do is, for other exponential equations, we would have to take the log and do a bunch of other stuff. But as over here, we could just see 5 to the power of 1 is going to equal 5, because anything to the power of 1 is itself. So this is my solution.